Good evening, boys. So now see lens matrix formula how to get. So here already I filled the data field. So you can see now this is the lens means the lens is nothing but two curved surfaces. Two curved surfaces are combined like this. And here also two concave curved surfaces are combined like this. So if you see clearly here, so now how the refraction taking place on both the curvatures I have given clearly. So if you take first curvature, the light is incident, refract like this. This is the path of first curvature. This is the refraction. Refractor, right? Final refractor, right? Coming to this one. Means here the normal angle of incident from which medium to which medium it is going and towards normal or away from the normal. So based on that arrow marks and everything normals have run. So here also you will I think you will get confused here. So I have maximum I try to draw the different colors, but maybe you need to something understand here. So you try to draw this one only the based on the formula, and light is traveling from rarer to denser, denser to rarer. You know how to draw the ray diagrams. Consider the normals, different places you can consider. However, you will get this phenomena will be same will come. So follow like this. So now curvature is first curvature refraction I am considering. So here angle of incident in N1 M medium. So surrounding medium. NM means here surrounding medium. NL means length of the uh, NL means refractive index of lens. So NM means refractive index of medium in surrounding medium. So you can see this is clear. So for this first curvature, write the lens maker's means curvature formula in which a medium angle is there. Therefore, the refractive index by the distance u, angle I represents the object distance, and refraction will take place in the NL medium. So that represents the refracting angle means gamma angle represents V. So in curved surface formula we have proven NL by V1. V1 is the image formed by the first curvature and NM as NL by R1. This is the first equation. Next, similarly for second surface also, second surface. For second surface, I1 is the object. Means the second surface getting the incident ray. This is the incident ray. Here is the incident ray which is refracted from first surface. The second surface getting the incident ray is refracted from first surface. So you can see the diagram. I will zoom. See. So now for second surface, you apply the equation. So you can see the diagram clearly. How second surface, the rays are refracting and everything. So now for second surface, you will write the again lens maker curved surface formula. So in this case, for second surface case, angle I in the NL medium. Therefore, NL by V1 will come. I represents object distance V1. NM by V final image. This is NL minus NM by R2. So these two equations add now. Then we will get finally NL by V1 and NL by V1 get cancelled. Therefore, NM by U minus NM by V is equal to NM minus NL by R1 plus, so NL minus NM. So now I am doing this. Here NM minus NL is there. Here NM minus NL I want, but here NL in the second equation NL minus NM is there. So to get that, here I am taking the minus common. So in that case only I can take the common NM and NL I can take common. 1 by R1 minus 1 by R2 is remained. So now here see, NM take common means 1 by U minus 1 by E. So this NM I am sending this side, and here NL minus NM I am writing. So to get 1 by V minus 1 by U this side, I am taking the common minus from this left hand side. So here also minus common taken means NL minus NM by NM into 1 by 1 minus 1 by R2. So finally this I am writing like this, NL by NM minus 1 into 1 by R1 minus 1 by R2. This is the formula for lens, means lens maker's formula we will call. So 1 by F is equal to, here NM minus NL by NM is taken as the relative refractive index. Here I have given the idea. Relative refractive index means the refractive index of the lens by refractive index of the medium. In many of the books, they will take this only. Here N is refractive index of the relative refractive index of the medium, with means lens with respect to medium. So now 1 by F equal to N1 minus 1 into 1 by R1 minus 1 by R2. This is the final formula. What is this formula useful? Lens formula is there now already. When we have, why you have to study about the lens maker's formula? The lens maker's formula is used to find out the nature of lens. Nature of lens. That means, so it is converge or diverge. Converging lens or diverging lens. And how the focal length of the lens it changes. How focal length of lens changes by depending on either increase or decrease. So that depends on the surrounding medium only. Its behavior, the lens behave like a convergent or divergent. The same lens, the concave lens can behave like a convergent or divergent, and convex lens also can behave like a convergent or divergent. That means that depends on the surrounding medium. If surrounding medium here I have written, in the surrounding medium, in the case of surrounding medium have less refractive index than the lens. The surrounding medium have less refractive index than lens. In the case of concave, I am explaining. So now this formula will, what will become? L is greater means this value will become positive. So here positive, negative are the values of this one I have written, because it is taking much time to write, that's why. And here 1 by R1. R1 means this side, left hand side. R2 is right hand side. Because in sign conventions, to easy application of sign conventions, optic center have to consider always as a origin. Left side is, and light has to come from left to right. That is in sign conventions, we know clearly. So then R1 will become negative and R2 will become positive. Therefore, here in the place of R1, if you write negative, then you will get here total of negative value, total of negative taken common. Negative and positive, negative will count. So in the medium where the refractive index of the lens is more than the surrounding medium, concave behave like a diverging. The concave behave like a diverging lens. Sorry. Similarly, if it is the surrounding medium have more refractive index than the lens, how the refraction take place on the concave lens, and how it will be converging. I have shown in this figure. You can see incident light. This is the path of incident, original means extended path of incident light. It has to go in this direction. But because of lens and medium here, it is coming from more refractive index to less refractive index. NL is less refractive index. So it is bending away from the normal. This is the normal. It is the actual path of the incident ray, but it is bending away. It is going away. More angle of refraction will take place here. So it is coming into here. Similarly, it is coming into again from less refractive index to more refractive index. It has to bend towards normal. So it is the original path actually. So it is bending towards normal. You can see this is the normal towards normal. Finally, the ray is converging onto principal axis. So this is the final image. So we can say for refractive index is more than the lens, the concave lens behave like a converging. Similarly, here also I have given. So if you see convex lens, if you take, for this curvature, C1 is this side and C2 is this side. It means R2, second surface radius is this side, C2, and first surface radius is right hand side. Therefore, R1 is positive, R2 is negative according to sign conventions. Therefore, if you substitute now, and here NM is, this is the case, NM less than NL, okay, na? NM less than NL, then this value Nm is less means Nl is greater, therefore positive value you will get. And here all 1 by R1 plus 1 by R2 is also positive. So F value will get the positive value. For that, where the convex lens behaves like a converging lens in the surrounding medium have less refractive index. In the same case, concave lens behave like a diverging. This is only will take normally. But according to this concept of lens maker's formula, application of lens maker's formula, in curved surface also 8 cases I have to explain, but I hope you'll understand here all these cases. So here see convex lens again, for example, Nm is greater than Nl I am taking in the case of convex. That means what? Surrounding medium is denser and the lens will be rare. That means surrounding medium is glass. In the glass, there is a air bubble, or in the glass there is a water bubble. So surrounding medium is more. The convex it is that lens, convex lens we are keeping the water convex lens. The surface means this is hollow convex lens, water report. Okay, na? So in that case, it will behave like a check once like this case. So incident ray normal to the first surface C1 I have written here, and therefore it is going into rare denser to rare medium. So it has to move away from the normal. So this is the normal. So away from the normal, here I have given already aroma. So you know, and it is coming into second surface. From the second surface, it is traveling from rarer to denser. So it has to towards normal. So for second surface, this is the normal C2. So C2 red color I have given here. And this is the extended path. Actually, this is the extended path of light, which has to come out into the medium. But it is the denser, the surrounding medium is denser medium. So it is moving towards normal. This is the towards normal angle R. And you can see the finally the ray is not at all converging anywhere. The extended reflector ray is only converging on principal axis. So it is diverging. Okay, na? So the reflector rays are not really meeting, then it will be the ray is said to be diverging. So now this convex lens diverging the rays. So it behave like a diverging in this case. So where the refractive index of surrounding medium is more. Example, I can go with this is the convex lens of water. So this is convex lens of water medium. 4/3. Now this is surrounded by glass, in the glass. So there is a hole like a convex lens like this. This is a glass medium. Then this lens behaves like 100% it is divergence, right? In the same way, so this is the glass medium. And here there is a concave hollow surface. Concave shaped hollow surface. Or filled with water. Then it will behave like converging. So more refractive index, converging it will behave like. So that is simple. Here you can go based on the sign of focal length, we can tell it is converging or diverging or refractor rays. See, refractor rays in this case, where surrounding medium is more meeting the principal axis, so converged, and here diverged, not meeting the principal axis, away from the principal axis, so diverged. So this is the explanation for convex lens is converging or diverging. One more actually the nature of, so this is means here I am going to give one concept. See, so this is if you take convex lens in air medium, principal axis, if you cut into pieces like this, so now this is the base. The base of convex lens is towards principal axis. If you take concave lens, the base of concave lens cut into pieces, if you cut into pieces like this, the base of concave lens is away from the principal axis. So the ray is bent away towards, always the ray should refract. Bend means refract away from principal axis in this case. That means towards base. Here also the rays which is coming parallel to principal axis. So it has to bend or refract towards principal axis. So base which side is there, that side it has to bend. So that is the reason we are telling, convex lens is converging and concave lens is diverging based on the refraction, means based on the base also, base of the prism. And one more here, more conclusion, the ray which is traveling to the optic center, means these are the thin lenses. Our explanation, everything belongs to thin lens only, means thickness of the lens we are not considering. So here the optic center is act like a tiny glass slab. That is the reason glass slab, there is no refraction will take place. Refraction will take place, but there is no deviation. The deviation is zero. Refraction will take place when light is traveling through the optic center. The refraction take place, but incident ray and refractor ray falls on the same line because glass slab thickness is very small. That I will explain in the glass slab some other cases, right? Thank you, guys. I hope you understand.